Definition of divisibility rule, crafted from the creation of the first authentic rules of divisibility by 7 of the history. Author Silvio Moura Velho. Let's start with the application of two Moura Velho rules of divisibility by 7 to a 10-digit number. Both rules fit the strict definition of divisibility rule. 16 to 21 5 plus 6 11 minus 7 4, 48 to 49 1 plus 5 is 6, 67 to 73 plus 1 4, 48 to 49 1 plus 3 4, 42. 7 divides 42 and 7 divides n. This is the quickest Moura Velho rule. Let's see the application of another rule to the same number. 3 plus 5, 8 to 14, 6 plus 4, 10, 12, 13, 21, 25 to 28, 3 plus 3, 6, 11, 18, 24, 27 to 28, 1 plus 2, 3, 11, 12, 18, 21. 7 divides 21 and 7 divides n. This is the first Moura Velho rule of divisibility by 7 and of the history of the theory of numbers, created in 2005. There is a video in YouTube about this rule. No details of these rules accessing my blog spot. There are other Moura Velho rules that will be presented in my next video. All the Moura Velho rules of divisibility by 7 are included in my unpublished and officially registered book, Divisibility by 7, The End of a Myth. Try to apply any known procedure to the focused number. If the application is not quicker than performing division, it is because your procedure does not fit the strict definition of divisibility rule. Now it's time for the definition. Mental procedure evidently quicker than performing division, whose algorithm makes possible the elimination of at least 2 digits in each application, used to determine if an integer, independently of its size and constitution, is divisible by another integer. Mental procedure. Because pencil and paper are not necessary. Write down results of calculations turn slow the application of any procedure. Evidently quicker than performing division, because it's not logical to create and give the name of a rule in the strict sense to a procedure that is slower than performing division, whose algorithm makes possible the elimination of at least 2 digits in each application. The elimination of just 1 digit in each application turns very slow the procedure, independently of its size and constitution. There are great numbers whose constitution retards the application of the chosen procedure. Example: eliminate the last digit, double it and subtract the result of the rest of the number. The most cited procedure, sometimes as a rule, sometimes as a trick, is considerably slower than performing division if the subtractions involve preponderantly 2-digit numbers, as it happens to the number used in this video. According to historians, the Talmud, Jewish holy book, registers the first attempt of creation of a rule of divisibility by 7. On page 88 of his book, Quick and Easy Math, 1964, Isaac Asimov, genial Russian author, after 2 millennia of history, stated that he could not work out a rule for divisibility by 7. Does not exist a good rule for divisibility by 7. The best way to verify if a number is divisible by 7 is performing division, and this is very bad. Considering Asimov's statements, it is comprehensible that professionals of the area were not able to create any rule for divisibility by 7 in 2 millennia of history. Incomprehensible is their difficulty to accept the Moura Velho rules. Well-founded contestations are welcome. Thanks for your attention.